Histamine is the ligand for the cell, which is a mediator for an immune response. It attaches to the protein receptors when released from the mast cells due to the signal or intruder. Histamine has 4 different types of protein receptors: H1, H2, H3, and H4 receptors. Each one gives a different chemical response when it enables the cell to give off these specific chemical reactions. For example, the protein receptor H1 accounts for the mobilization of calcium throughout the cell. These receptors bind with the G-coupled proteins called heterothermic, which mediate signaling pathways that are activated by the 4 histamine protein receptors. Each of these receptors are in different locations due to their chemical occupation. H1 receptors are for behavior and nutrition. H2 receptors are for the regulation of neural plasticity for long-term memory and spatial navigation. H3 receptors are still being researched for its full importance, and H4 receptors are specifically located throughout the body with blood cells, neurons, lungs, and liver. In the transinduction pathway of histamine, starts with 4 histamine receptor subtypes, of course, H1, H2, H3, and H4, and which respond to the ligand histamine by activating the 3 canonical heterothermic G protein mediated signaling pathways, as it consists of alpha-beta subunits when it binds to protein. These alpha units activate distinct cellular responses, in which depend on the specific receptor. For example, in H1 receptor, the pathway leads to the mobilization of calcium channels, while H2 receptors lead to Krebs and protein phosphorylation. This is through the breakdown of adenylate cyclase, which produces CAMP, which leads to the production of pKa and then phosphorylated protein and Krebs. These reactions shown in the demonstration allow the mediator histamine to perform its job against any pathogens in the body. In this demonstration, the nail dives through the skin while many pathogens are released. This triggers the release of chemokines, in which activate mast cells and dendritic cells to degranulate. When the mast cells degranulate, they produce the mediator histamine to fight the bacteria amongst tissues. At this point, histamine can be activated even if the so-called pathogen is harmless, as shown in allergic reactions. As the bacteria in the interstitial fluid, the release of histamine causes its capillary wall to expand, which causing vasodilation, as shown through swelling on the outside surface. During this period, phagocytes are able to squeeze through the capillary wall, as well as B cells and T cells, which attack the specific intruder.
Histamine is a major mediator of the acute inflammatory response. It influences numerous functions of the cells involved in the regulation of immune response and hematopoiesis, including macrophages, dendritic cells, T lymphocytes, B lymphocytes, and endothelial cells. All the stated cells contain histamine receptors and also excrete histamine. They selectively recruit the major effector cells into tissue cells, and it affects maturation, activation, polarization, and effector functions. Symptoms of histamine are hives, which are rashes, swelling, coughing, wheezing, and diarrhea. Chemokines are the signaling mechanism for histamine. They cause mast cells to degranulate, which releases histamine into the body. The 4 histamine receptors, H1, 2, 3, and 4, they are the 4 receptors, of which H1 through H3 are located in the human stomach. Histamine is a potent vasoactive agent and a primary amine synthesized from histidine in the Golgi apparatus in the cells. It is also a major mediator of allergic diseases and viruses or parasites. Histamine is the primary reason for inflammatory responses due to a foreign invader like an allergic pathogen or virus. It can be both good and bad for us. In the case of an allergic reaction, it's considered bad because it overreacts and causes all the symptoms based off of a harmless particle that the body cannot identify. But in the case of a foreign virus, when vasodilation occurs, it allows the white blood cells or other types of cells to fight the parasite or virus, as well as helping fight it, since histamine is considered toxic to almost all parasites known.